Welcome to the Translating Your Search Strategy workshop presented by the CAMH Mental Health Sciences Library. For today's agenda, we'll look at learning outcomes, considerations before we translate, learn the differences between a platform and database, questions to consider when selecting databases, go through what search syntax is and advanced search features, review 3 translation examples, discuss some next steps, and lastly end with additional resources. Learning outcomes. I hope by the end of this session, learners will be able to test their search strategy for search sensitivity, know the difference between names of platforms and databases, such as Ovid, Medline, Ebsco, or ProQuest, be able to select the most relevant databases for your topic or subject, be able to apply and understand advanced search techniques using appropriate search syntax, and see examples of how to translate a search strategy from Ovid Medline to Ovid PsycINFO, from Ovid Medline to Ebsco CINAHL, and from Ovid Medline to Web of Science. So let's get started. So you've completed your search strategy and you're ready to translate? Not so fast. Let's go through a few considerations before you begin translating your search strategy. This session is the next step after preparing a comprehensive search. For more information about developing your search strategy, please view the video Using Medline to Search the Health Sciences Literature available on the CAMH YouTube channel. A link to this channel will be made available on the resources slide. Medline is typically where we start our original search before we translate it to other databases. After you've edited your search, you could have it reviewed for logic and spelling errors. Then you can test for search sensitivity. In terms of effective searching, we tend to look at precision versus sensitivity. For the purpose of this session, we'll do a quick look at search sensitivity. But there is a link on the resources slide for more information on precision versus sensitivity. By conducting a sensitive search, we're trying to capture all relevant documents using a broad search, much like casting a fish net. Let's say our topic was about applying cognitive behavioral therapy to treat bipolar disorder in adolescents. I have done some preliminary searches and chosen a few articles that are highly relevant to my topic, and I'd like my search strategy to capture these articles. On this slide are 3 of my targeted articles. To simplify what I mean by testing for search sensitivity, you're going to check to see if your search strategy captures the preliminary articles you found that you'd like to include in your search. You can conduct this test at the end of your search strategy. To do this, we'll enter the titles of the targeted articles in Medline and search by title. You can do this in one of 2 ways: search using the code .ti. or m_titl. On the left, within the red square brackets, are lines 15 to 17, and these are their targeted articles. Within the orange brackets on the right side, we see 1, which indicates that these 3 targeted articles are indexed or available in Medline. I've grouped them together as a set shown in line 18 and labeled them relevant articles. Since they are available, we'll now compare the search results set, which is line 14, with the relevant or targeted articles set, which is line 18, by using the Boolean operator AND, which is line 19. Line 19 shows that if you combine lines 14 and 18 with AND, the number should be equal to relevant articles. The next slide is a more enlarged view. Combining the search results with the relevant articles should equal the same number, and when it does, it indicates that our search strategy has passed our test of search sensitivity. Now, what if your test for search sensitivity fails to capture the targeted articles? I listed a few common problems and solutions. First, check the spelling in the words of the title. Secondly, try searching for parts of the title. Sometimes a colon, a semicolon, or space causes problems. You can also search other field codes such as author, or if available, unique identifier. Once you've found the article citation, look at the article's complete record to see how the article was indexed and the terms used by the author, and revise your search strategy accordingly. Test the search again to see if it was included. Some things to note: it is possible that a targeted article may not be captured because it's missing a concept in the record, or it really isn't available in Medline. Now, if a relevant article is in Medline but isn't showing up in your search, you can still include it through a supplementary search method, and more about supplementary search methods is provided on the resources slide. Next, we'll move on to knowing the difference between platforms and databases. Platform versus database. Here's a quick exercise to help you differentiate between platforms and databases. This is an example from an abstract of published literature that I've not identified. Can you spot the error? It's a common error, and you could think about your answer. Did you catch it? The highlighted text states that there are 3 electronic databases that were searched: Medline/Ovid, Ebsco, and ProQuest. However, the issue is that Ebsco and ProQuest are platforms and not databases. Medline is a database on the Ovid platform. We'll clarify the differences by describing them. A platform is the interface used by the database provider. By interface, we mean the front end of the database that users see and use. A database is the searchable collection of information. The database uses an interface for users to search by. The library databases we use for research are primarily bibliographic databases, as they provide descriptive records in the form of citations for various literatures and publication types. We can also think of the platform like a streaming service such as Netflix, Prime Video, or Apple TV, where there may be a few overlapping TV shows or movies, just as some platforms may offer the same database. We need to distinguish between a platform and database so we know how to address them properly. When you write your search methods section of your paper, and one of your readers is interested in replicating your search, they would want to know what databases you used, and it would be helpful to identify them properly using the platform and database name, or at least the database name. This slide lists some examples of a platform and a database. Just to note, Medline database is available through Ovid platform, but also in PubMed, which is the free public interface. Here's a quick chart for your reference. Some databases are offered by multiple platforms and/or companies. If you're affiliated with another institution and their library offers access to Medline, it may be through Ovid and/or Ebsco. If you have a choice for using Medline, the preferred choice would be Ovid platform as it has a more dynamic interface. Here's a look at Ovid Medline. Here's a look at CINAHL Complete Database on the Ebsco platform. This is the end of the section on platform and databases. Now that we're familiar with platforms and databases, we'll go through how to select a database. Selecting databases. When it comes to selecting databases, we'll need to look at two main questions. The first is about your topic. What is the topic or subject area? Is it biomedicine, nursing, psychology, psychiatry, technology? And what types of publications are you looking for? Peer-reviewed articles, systematic reviews, theses, or book chapters? We can ask similar questions about the databases. Does the database we're interested in have the journals or content that cover my topic or subject area? And what types of publications does this database include? This brief database comparison guide was adapted from a document that you can find on the Resources section. The blue area are databases CAMH has access to. The gray section are databases we don't have access to, but I included it as some of our service users have access to them through other institutions. You can see here that some databases are limited in subject scope and others are multidisciplinary. As well, record types vary by database. For instance, some databases include mostly journal articles and others include book chapters and conference proceedings. Now, if you can't access a specific database, you can mention that as a limitation in your research paper. And a potential solution for not having access to other databases is using Google Scholar. The CAMH library recently offered a workshop on this, and the recording will be available on the CAMH YouTube channel. So why do we want to search multiple databases? Because a search of Medline alone is not considered adequate. While this quote is meant to apply to conducting systematic reviews, it is applicable to conducting comprehensive research in general and is overall considered a best practice. The purpose of searching multiple databases is to maximize all relevant literature available, as well as minimize selection bias. By searching only one database, such as just Medline, you're retrieving an underrepresentative sample of all potential reports, articles, and literature than if you had conducted an extensive search of several sources. Another example would be exclusively searching Embase, a database not available at CAMH, but some users have access to it. It contains mostly European content and would provide you with a geographic bias. These potentially useful databases are not available at CAMH with the exception of ERIC, the Education Resource Information Center database. I've listed them here because some service users are affiliated with institutions that offer these databases or have people on their research teams who have access to them. Since we're on the topic of selecting databases, I thought I would include a section on PubMed. PubMed is a free open access database that contains Medline records but doesn't offer all the dynamic features you would find in a Medline database. So if given a choice of using Medline versus PubMed, choose Medline for its advanced search functions and export features. Search syntax. Syntax describes the way database commands are written on each platform. This includes search field tags, proximity operators, wildcards, and truncation. For example, searching for depression in the title of a record would look like this in various databases. In Ovid Medline, you would use .t.I as well as in Ovid PsycINFO. However, in CINAHL Ebsco, you would see the TI field code, and in PubMed, you would use title within square brackets. Since you'll be using multiple databases, it's a good idea to review the syntax of databases as a roadmap of what you're going to need. You can find this section in the Help section of each database, where there are various guides and charts that compare the syntax of each database. And I'll show you one example in an upcoming slide that will be a guide and will also be available on the resources slide. Here's an example of Ovid platform search syntax for some commonly used field codes: multipurpose, title, and abstract. In this quick reference chart, I included a few commonly used search syntax examples for different databases. Keywords are unofficial natural language terms you can search. Some keywords can be subject headings depending on the availability within the database. You can search for keywords in a variety of ways depending on the database, and most databases use a default keyword search field code. In Ovid database, the default is .mp, which is multipurpose, or some think of it as most popular. Here's a more complete chart that I referred to earlier, and you can find a link to this in the resources slide. This slide outlines more syntax features and a brief exclamation. There's truncation, adjacency operators for proximity searching, and wildcards. One thing to note about adjacency operators: in Medline, the adjacency operator is ADJN, where n-1 is the number of words between your terms in any order. Another example is ADJ3 is not 3 words between, but 3 words apart, so technically 2 words between. By now, you may be wondering why we can't search multiple databases at once. We'll need to search databases separately, since search syntaxes are different. As you could see in the previous slides, there are various symbols and codes you can use, and they don't all easily translate into other databases, hence why we need to search them individually. Translation example 1. Now that we're familiar with selecting appropriate databases for our topic, search syntax, and advanced searching techniques, Let's look at some examples of how to apply what we've learned. As mentioned earlier, we'll be using Medline as our starting strategy, and then we'll adapt it to other databases. This strategy includes a combination of the use of various syntax. In line number 1, we have controlled vocabulary in the form of a medical subject heading, as indicated by the /. Line 2, 3, and 4 show examples of truncation using an asterisk. For example, in line 3, teen asterisk, this would capture teen, teens, teenager, teenagers, etc. In line 9, we use a proximity operator in the form of an adjacency to find the term cognitive within 3 words of behavior therapy. Also in line 9, we use the wildcard question mark symbol to capture behavior with and without the letter U. In line 11, we have an example of field codes, AB for abstract, TI for title, and KF for author-supplied keyword word. For our first example, we're translating Ovid Medline into Ovid PsycINFO. They're both on the same platform, and most of the search syntax would be the same. The first line we translate is the medical subject heading for adolescent. Let's make sure the map to term subject heading is checked off. Let's see what comes up in PsycINFO. When you search PsycINFO for adolescent, you won't find an identical subject heading. Instead, you'll be tasked with choosing which is most relevant. In this case, we'll choose adolescent psychiatry and adolescent psychology. If we look at 9, a Medline with the truncation, proximity operator, and question mark wildcard, the translation is the same because we're using Medline and PsycINFO on the same platform, Ovid. Again, to review what the appropriate symbols are, you can bookmark the links provided or keep a copy of the cheat sheet available as a reference. For search field codes, we see Medline has a code for abstract, title, and KF for keywords heading word. In PsycINFO, there's a field code for abstract and title. For something similar to .kf for keyword heading word, we could use .idi for key concepts and or .hw for heading word. The field code for the default search multipurpose .mp is the same for Medline and PsycINFO. So what does this translated search look like? Let's put it all together. Here's an example of translated Medline to PsycINFO search. To recap, when you search PsycINFO for a subject term for adolescent, you won't find an identical subject heading. Instead, you'll need to choose which is most relevant. In this case, we chose adolescent psychiatry and adolescent psychology. Now, we didn't show this example, but if you look at line 7 on the left, the medical subject heading for CBT is cognitive behavioral therapy. In line 8, the right column, the equivalent subject heading in PsycINFO is cognitive behavioral therapy. The difference is behavior versus behavioral. As mentioned for line 9 in Medline and line 10 in PsycINFO, the search syntax for ADJ, wildcard, and truncation are the same because we're on the same platform, Ovid. For search field codes in Medline 911, we have abstract, title, and keyword heading word, and in PsycINFO, we added .hw for heading word and .id for key concept. This is a summary of what we just went through. Translation example 2. Next, we'll look at translating Ovid Medline to Ebsco CINAHL. Here's another look at our Ovid Medline search. As you may recall, Medline's controlled vocabulary is called medical subject headings, or MESH. In PsycINFO, the controlled vocabulary is called APA Thesaurus of Psychological Index Terms. In CINAHL, they are simply known as CINAHL subject headings. So let's search for an equivalent subject heading for adolescent. When you search for CINAHL subject headings for a term equivalent to adolescent, it shows us we should use adolescence. Further down the list, we also see some additionally relevant terms, adolescent psychology and adolescent psychiatry, which are also subject headings in PsycINFO. So we'll add that too. We will also look at cognitive behavior therapy, and it suggests we use cognitive therapy. Now we'll move on to truncation, proximity, and wildcard. In Ebsco CINAHL, we can use asterisk for truncation. However, we need to use N and a number in place of Medline's ADJ number operator. For wildcards, you have the option of question mark or hashtag. For this default search, we do not need to change select a field optional. Next, we'll need to find field codes for abstract title and keyword heading. There's a drop-down menu for select a field, and we can choose TI for title, AB for abstract, and KF. We can choose either MW for CINAHL heading word or SU for subject, or even MH, which is CINAHL exact subject headings. As a reminder, you don't have to remember all these field codes. Please refer to the help section of each database for the descriptions and/or the cheat sheet charts. So when we put it all together, we have the following. Adolescent subject heading, we translated to CINAHL subject headings, adolescence, adolescent psychiatry, and adolescent psychology. Cognitive behavior therapy became subject heading, cognitive therapy. ADJ operator became N, seen in line 11 on the right. For wildcard, you could use the hashtag or question mark. For field codes, we use AB, TI, and MD, MW, and SU. Here's a summary of the Ovid Medline to Ebsco CINAHL. Next up, translation example 3. For our last example, we'll look at translating Ovid Medline to Web of Science. Web of Science is not a proper biomedical or health science database, but rather a multidisciplinary database and could still contain relevant literature on our topic. CAMH does not offer access to Web of Science, but we have included this example as some CAMH staff have access to it through affiliated institutions. Again, we'll use the Medline search as the base search before we adapt it to Web of Science. Web of Science doesn't have a controlled vocabulary like medical subject headings or the APA PsycINFO Thesaurus or CINAHL subject headings, so we'll just use the topic field tag. When we look at using truncation, it's the same operator, asterisk. For proximity searching, we need to use near, / and a number. And unfortunately, if we tried to search all fields, you'll receive an error. So you would use TS for topic search instead of all fields. Next, we'll translate the field codes. We'll use TS again, since it includes title, abstract, author keywords, and keyword plus, which are words or phrases that frequently appear in the titles of an article's reference, but do not appear in the title of the article itself. So here's a look at the final translation. To recap, there are no subject headings in Web of Science, so we can use the field tag TS for topic search. For truncation, we can use the asterisk, and for proximity search, we'll use capital near, / and a number, whereas in Medline and PsycINFO, we use ADJ and a number. And for default keyword search, we can just use the all field tag. Here's a summary of what we just did. Lastly are the next steps. Here are some next steps you can do once you're done converting your search. Regarding systematic review software, if you're not already aware, CAMH offers access to Confidence, which is a web-based software platform that streamlines the production of systematic reviews, and you can use it to screen citations and/or import full text. All additional information is available on the resources slide, including a template to document your strategies, the document on the database syntax cheat sheet, and information on supplementary searching. Here are a few key points to remember from what we discussed today. Check your search strategy for targeted articles. Make a plan to look for articles outside of academic databases. Familiarize yourself with the names of platforms and databases you're using. Search each database separately. Review or bookmark the help sections of where you can find the syntax and advanced search techniques unique to each database. Resources. Here are a listing of resources on the databases, advanced searching, as well as search syntax and field codes, links to knowledge synthesis resources, as well as more information on comprehensive searching. You can find more CAMH library videos and tutorials on our YouTube channel. Here are some additional services available through the CAMH library. Thank you. If you have any questions, please feel free to contact the library at library@camh.ca. Thank you for watching and happy searching!